In this example, we have ourselves a nice quadratic function written in standard form, this f of x equals 3x squared minus 7x plus 2. And we're going to go ahead and evaluate this function at 4 different values of x. You'll notice we have a nice whole number, x equals 1. We have a fraction, x equals 1/3, a decimal, x equals 0.75, and also this irrational number, x equals the square root of 6. And so we're just going to go ahead and plug each one in independently, and we're going to see what these look like. So let's go ahead and do f at 1 first. And that one should not be too bad at all. Okay, so when we evaluate here, we're just taking this 1 and we're going to plug it in for x, and that's every single x that we see. So it'll be 3 times, and remember when you plug things in, always use parentheses. So put that 1 in parentheses, square it, minus 7 times 1 in parentheses, and plus the 2 right there. Okay, so when we have these, we know the exponents are going to be of higher precedence, or higher on the order of operations food chain than, say, the multiplication or the addition and subtraction. And so we'll always do this exponentiation first. So 1 squared is, well, 1, as 1 times 1. So 3 times 1 minus 7 times 1 plus 2. This is not so bad. 3 times 1 is 3. And 7 times 1 is 7 plus 2. 3 minus 7 is negative 4 plus 2 is negative 2. So I can say that f at 1 will be negative 2. We can also write this as an ordered pair. So 1, negative 2. And that'll be that first one. Okay, so let's go ahead and do x equals 1/3 next. So we'll say f at 1/3. So we'll have 3 times, and we're going to plug this 1/3 in. So 1/3 squared minus 7 times 1/3 plus 2. Okay, let's just go ahead and scoot everything up. Okay, once again, we'll do this exponentiation first. So 1/3 squared is 1/3 times 1/3, and that'll be 1/9. And then we'll have 7 times the 1/3 plus 2. Okay, well, 3 times 1/9, we could put that 3 over 1. So 3 over 1 times 1 over 9, we can reduce some things. Looks like we'll have 1/3 minus, and then same thing, put 7 over 1. So it looks like 7/3 when I multiply, and then plus 2. Well, let's see, 1/3 minus 7/3. They have common denominators already, so 1 minus 7 is negative 6, and negative 6 over 3, well, that's just going to be negative 2 plus 2, and that's 0. Okay, so we actually know with this quadratic function up here, we can say that x equals 1/3 is actually going to be a root or a 0 of the function, because when I plugged it in, it gave me 0. So I can say f at 1/3 equals 0, or I can write that, of course, as an ordered pair, 1/3, 0. Okay? 2 more to go. So we're going to go ahead and do this 0.75 next. So we're going to go ahead and rewrite this function, and we'll plug this 0.75 in there. So 3 times 0.75 squared minus 7 times 0.75, and then plus 2. Okay, so let's go ahead and see what this looks like. So we'll start by doing the squared once again, and so we have 3 times this 0.75 squared, and that'll be, let's see, 0.5625, and we'll just bring the rest of this stuff down. Okay, now we can do some multiplication here and here, and let's see, 3 times this should give us, let's see, 1.6875, well, minus, let's see, 7 times 0.75, should be 5 1/4. And we have that, and then let's put it all together. So 1.6875 minus 5 1/4 should be what? Negative 3.5625 plus 2. So I end up with negative 1.5625. Okay, whew, those decimals. Okay, so once again we can say f at 0.75 equals negative 1.5625, or we can write this as an ordered pair. 0.75 comma negative 1.5625. Lots of decimal digits in that one. Okay, so there's that guy. And let's do one final. So we're going to say f being evaluated at the square root of 6. So we have 3 times, and in parentheses we'll put that square root of 6 and square it, minus 7 times the square root of 6 plus 2. Okay, this one's actually pretty nice because the square root of 6 squared, well, the square and the square root cancel each other out. So I have 3 times 6 minus 7 radical 6 plus 2. 3 and 6, let's make 18 when I multiply. So when I put it all together, the 18 and the 2 can go together, so 20 minus 7 radical 6, and that'll be that final evaluation. So I can say that f at the square root of 6 equals 20 minus 7 radical 6, or of course, I can write this as an ordered pair. The square root of 6 is my x value, and 20 minus 7 radical 6 is my y value. So that's that one as well. So here's what we did. We started with this original quadratic function in standard form. We went ahead and evaluated that function at 4 different values. We had a nice whole number, a fraction, a decimal, and an irrational number, this square root of 6. And we walk through, and remember when you evaluate, plug your value into parentheses, and always think of this exponentiation first with these quadratic functions. And so we can write it as f at our value equals, or remember, this input-output can represent an ordered pair as well.